You have your local editor dialed in exactly the way you like it. But when training massive models, your workflow can hit a wall. You have to pack up your scripts, leave your local setup behind, and move everything into a cloud notebook to access the compute power you need. The Azure Databricks AI Runtime CLI, which is currently in beta, solves this by giving you a direct path to on-demand serverless GPU compute. You can skip the notebook entirely and submit distributed training workloads straight from your local terminal. Before you run anything, you need to ensure your account has active Azure Directory authorization to access the specific workspace you intend to use. There is a clear split in how you interact with Databricks here. If your workflow is based entirely inside a notebook, you will need to use the @distributed and @raylaunch Python APIs instead. The CLI is designed specifically for off-notebook workflows. Moving away from ephemeral notebooks and using the CLI lets you treat machine voting jobs like standard software. You define your training tasks declaratively, track them clearly, and check them into source control. Let's start the setup by opening your local terminal. Step 1 is fetching the tool. You run the command to download the AIR executable package directly to your machine. Next, execute the installation command to unpack that toolkit and finalize the setup on your local system. To verify it installed correctly, query the terminal for the application version. If it returns the current version number, your installation is complete. Your local terminal must establish a secure connection with your remote Azure Databricks workspace. During this handshake, an Active Directory token travels back, verifying your identity. If you are missing required permissions, the token is blocked and the handshake fails. When that authentication is successful, your local laptop acts as a direct command center for remote serverless compute. Now we move from the terminal interface over to the code editor, where your Python training script is stored. Instead of web interfaces, use a YAML file to map your code to hardware. Configure fields to allocate the exact serverless GPUs needed, and declare if the source is workspace-based or get pulled. Beware, strict YAML formatting means one bad indentation causes a failure. By writing your compute requirements as declarative infrastructure, your hardware architecture gets locked into Git history right alongside your Python scripts. With the YAML file configured and saved, go back to your integrated terminal to prepare the submission. You trigger the process using the AIR execution command. This physically pushes your YAML configuration out of your local machine and up to the cloud. Read the resulting terminal output to confirm that your payload was received and accepted by the AI runtime without any immediate errors. To monitor the live payload, we finally shift our view away from the local code editor and open up the Azure Databricks web interface. This is the Jobs Run page. Here, you verify that your requested serverless GPUs have successfully spun up and are actively processing your workload. From this dashboard, you can transition directly into the integrated MLflow tracking server interface. As the remote job executes, your training metrics, parameters, and model artifacts are automatically captured and logged straight into MLflow. You execute massive cloud workloads and monitor them live without giving up the comfort of your local developer environment. This chart shows the complete cycle, creating the YAML locally, submitting via the CLI, and tracking the results through MLflow. Again, if your work strictly requires a notebook environment, you must bypass the CLI and rely on the Python APIs for distributed processing. Because the AI Runtime CLI is currently in beta, the feature set and capabilities supporting this workflow are actively expanding. For complex jobs, consult the workload YAML and CLI command reference pages in the Databricks documentation to see the latest advanced configuration options. Bridging your local tools with serverless scale creates a streamlined system, keeping your focus on writing code instead of managing infrastructure.